Hello guys, I think we're gonna get started now. So if you're, please have a seat. 이제 곧 발표 시작할 거라서 자리에 앉아주시면 감사하겠습니다. Let's get this going, yay! Yeah. Hello, my name is David Park. I'm head of APAC at Mina Foundation, and this is our, I think, officially second big event, dev workshop that we're hosting this year. And Mina Foundation has been always very bullish about Korea, so we wanted to make sure we give the full picture, and hence we invited all the great people that can explain all parts of Mina protocol. So I think this will be a great opportunity to learn about Mina, as much as our CK program language, ONJS, and protocol. So okay, and this is the agendas today. We're first going to start off with why Mina is a great place for validators with our senior solution architect, also. And we'll talk about some of the community grant programs that Mina Foundation provides with our developer growth manager, Yasin. And we'll talk about our scaling L2 solutions that's being ready to be launched by this year, Prosecco. And lastly, our founder, Mina Protocol's founder, will give a speech on the state of the Mina ecosystem. And next is what to expect for the future of Mina Protocol by our protocol development company, OLM CEO Brandon. And then last, we'll give more comprehensive overview of ONJS and protocol by one of our community members from Korea called Mina. And then from 6, we'll have networking party at the rooftop. So Noon's community has been working hard to make sure we have the best quality barbecue. So it will be nice to just hang out at the rooftop. Okay, and we'll just get started. 그냥 간단히 한국말로 이제 얘기하면은 저희 미나 재단이 이제 한국에 되게 좀 진심이어서 이제 월별로 저희가 개발자 커뮤니티 행사도 진행하고 상반기에 이제 큰 행사를 진행하고 하반기에도 저희가 이번에 이렇게 큰 워크숍을 진행하면서 미나 프로토콜의 전체적인 그림을 다 전달하고자 이런 행사를 준비하게 됐고요. 그래서 노드부터 시작해서 이제 저희 GKL 그리고 미나 창업자가 이제 앞으로 갖고 있는 미나에 대한 비전이랑 이제 저희 미나의 확장성 솔루션인 제코라는 이제 L2 창업자까지 포함해서 다 모여서 저희 미나 생태계를 그래도 한 그림으로 전달하고자 이런 자리를 마련했으니까요. 네. 좀 관심 있게 봐주시면 감사할 것 같고 저희 발표들 다 진행하고 나서 실제로 이제 개발자들 분들 위해서 저희 미나 개발 프로그램인 ONJS랑 또 롤업 이제 웹체인 프레임워크인 프로토킷을 또 발표를 할 거거든요. 그래서 개발자분들 한번 참고해 주시고 또 저희 오늘 다 자리에 있으니까 혹시 미나와 관련된 궁금한 것도 있으면 저희한테 말씀해 주시면 될 것 같습니다. 그래서 이렇게 발표 진행하고 이후에는 이제 6시부터 루프탑에서 네트워킹 파티를 하면서 바베큐 같이 먹을 예정이니까요. 네, 끝까지 남아서 바베큐 드시고 가시면 좋을 것 같습니다. So we'll just get started. No.
Hi everybody, I'm Phil, I'm a Solutions Architect at the Mina Foundation, and I'm going to talk a little bit about validators, the delegation program, and why you should be validators. I know some of you are already validators, and I was chatting with you yesterday, or some of your colleagues. So once the slides are up, I'll introduce Mina a little bit and talk about, cool, thank you. Mina, the Universal Proof Lab. Technical glitch. So what I'll talk about is Mina protocol, what it is, and then what is ZK apps, and some next steps. So it's the Universal Proof Lab. So Mina is an L1 blockchain built on ZKPs. It's three main things. You use O1JS to build ZK apps. Pickles is a library which is used to add recursive proofs, unlimited recursion, and then Kimchi is the proving layer. So it's an L1 blockchain. This is not an L2, we're not a ZK rollup, we are an L1 blockchain, proof of stake, and it's succinct. And I'll talk a little bit more about that in a minute. And one of the advantages of being succinct is it maintains decentralization. So the other thing that we think Mina has solved is the blockchain trilemma. So Mina is a blockchain that is decentralized and will always be decentralized, is scalable, and it's secure through the cryptography that it uses. For validators, there's a number of nodes that you can run. There's Mina daemons, which are validator nodes, archive nodes, snark workers, CPs, and I'll talk a little bit more about that as we go along. So what do I mean by Mina as a succinct blockchain? Mina isn't like a traditional blockchain that stores the full audit trail of every transaction. So what that means is, as the blockchain gets older, you have to replay all of those transactions in order to sync with the network. The way I like to think about Mina is it works like a traditional blockchain for 290 blocks, and while those 290 blocks are being produced, snark workers run across those blocks, snarking all of the information, and they create a proof of everything. So what that means is that you have a proof of the blockchain that you can verify. And with proofs, with lots of cryptography, the proof is kind of, let's say, complicated to create, but verifying that proof is very short. So if I want to sync with the blockchain, I verify the proof, and then I just need to replay 290 blocks. So it's very easy to sync node validators with the Mina blockchain, and this is one of the reasons why we think it will always be decentralized, because it's not going to take 2 weeks to sync with the blockchain or longer. It's always going to take a short period of time. So it's not just ZK apps, let's not forget payments, right? So before the upgrade, which I'll mention in a little while, Mina supported payments. And another feature of the succinctness of the Mina blockchain is that you can validate this proof on a mobile phone. So again, you've got a highly decentralized blockchain with the inability to double spend, so traditional blockchain, but it also supports transactions for payments. So it's worth not forgetting that. So it's the world's lightest blockchain. It's truly decentralized. There are hundreds of node validators. This is not a traditional proof of stake where you've got a limited pool of 21. There is an unlimited number of block producers. Anyone can become a block producer. There's no limits to it. It's a permissionless blockchain. And because of that, there's an unbounded number of node operators. So this is why we think it's a good place to be a validator, because everybody can join in. Funds are locked, but they're not subject to slashing. Sorry, funds are not locked when you stake them, and are not subject to slashing. So like a traditional proof of stake blockchain, the amount you stake will increase the likelihood of you being able to produce a block. And if you produce a block, you can kind of get rewards for that. So the node types are, there's the Mina daemon node, which will verify transactions, update the state of the blockchain, and keep the blockchain moving along. There's snark coordinators and snark workers, and these are the nodes which will produce the snarks which create the proofs. And this is the the side of the blockchain that makes it succinct, and also it's the same technology that we use for building ZK apps. And then for historical data, you can run an archive node. So the hardware requirements are, you need a powerful machine, but what you don't need is lots of memory. Or storage, I should say. So the opportunity to produce a slot is determined by a verifiable random function. So depending on the amount you stake, the more you stake, the more likelihood you have of beating the threshold, winning the VRF. Now it's worth mentioning that there could be multiple block producers that get the same opportunity to produce a block in that slot. So, you know, kind of having an efficient block producer that's running kind of well and with high spec is going to increase your likelihood of putting that block into the canonical chain and winning those rewards. And the rewards for generating a block are, again, standard blockchain rewards, coin-based transaction fees, less any fees for purchasing smart work, and less any payments that you give for delegators. So again, classic proof of stake. If you're running a node and the community like you, I can stake my tokens to you, so you increase the likelihood of producing the block. So there's a revenue example there. So we won't go straight into that too much. And then one of the key things is June 4th, 24, there was a Berkeley update. And thank you for all the node validators who helped us with that. So I know Diaz RB are here and participated in that. And that added the ability to do ZK apps. So what are ZK apps? So ZK apps prove off-chain execution, then verify on-chain. So the traditional blockchain model is you execute the smart contract on the blockchain. So if I have 5 lines of code, for example, it's going to cost me 5 gas. If I have 500 lines of code, it's going to cost me 500 gas. If I have 5,000 lines of code, you're probably going to run out of gas. With this off-chain execution model, I generate a proof that the compute was done correctly, and I send that proof to the blockchain, which is then verified by the Mina block producers. And think of that as one transaction, so let's say 1 gas. If I have 5 lines of code, I generate the proof, and I send that to the block producer, and that's 1 gas. If I have 500 lines of code, it generates a proof, but it still sends that proof with the account update to the blockchain, and it's 1 transaction to verify that. So again, 1 gas and 5,000. So we think that this creates an environment where we're going to see a lot of new use cases and a lot of adoption of the blockchain, which again makes it a more appealing environment for validators to be part of the ecosystem. So the ZK apps are written in L1.js, which is a TypeScript library, and that creates the ZKPs. And the advantage of the ZK apps are privacy. So we're talking about zero-knowledge proofs, so we can prove something without revealing any additional information. So I can prove that I'm over 18, but I don't have to show you my driver's license that might reveal my address, for example. It's less gas. We talked about this off-chain computation versus on-chain computation. So each proof is verified once on the blockchain, and that's a single transaction. Scaling, we can provide scaling with rollups. The Mina blockchain almost works like a rollup because it creates this single proof where you can verify and makes it easy to sync and join the network. And composability, it's simple to call other ZK apps methods. The ecosystem is growing, and I think this is something that appeals to the block producers because, again, more transactions, more usage, better ecosystem means it's a better place to be a validator. So here's a list of some of the apps that are currently being worked on and being deployed into the Mina network. I won't dwell too much on ZK apps because this is about validators. And then there's also a growing ecosystem in South Korea. So last night we had talks from Pungpol, Mover, Ponzi. We were working with Mirai Asset Securities to build an STO platform and ZKML. So what I'm trying to highlight here is this is a healthy ecosystem that's growing, and since June the 4th it's had the ability to build ZK apps, so we think it has potential to grow lots more. So next steps, if you want to be a node operator, the documentation is a good place to start, and there's a link to it. And there's also the Mina Foundation delegation program. So again, if you scan that QR code, it'll take you to the delegation program. And essentially what that means is the top validators, when we measure uptime, the Mina Foundation will delegate some tokens to them. It's a very full program, so it's one of the ways that you can get extra staking. Cool, thank you for listening.
Yeah, so next is the next section is the Yashin. Yashin will give some presentation about our Mina community grant programs, and then we have another the onboarding program. So yeah, thank you.
Okay, so hello everyone. I'm Yasin. I've been working at Mina Foundation for almost 2 years right now, and I've been really doing my best to onboard any developer who is interested in ZK in the world. And I can say we made great progress, and we already developed our grant programs in a very positive way. So I'll talk about how we can get started building on Mina protocol or contribute to projects in the ecosystem. So I already gave an intro, but I also want to say thanks to everyone who joined us today, and also our APAC team, David, Ryan, and Logan, for organizing this great event. I'm also from Turkey, so it's always a special feeling for me to be in Korea for the relationships between our two countries. I will start from the zero. So, and the first program that I want to talk about is developer onboarding modules. And these modules is actually a month-long learning program with 1K Mina token reward upon completion. The goal is, I know like the best developers are very busy, so we wanted to create a flexible onboarding content and mentorship for these developers who are interested in Mina in general. And the content we cover in the modules are zero-knowledge proofs and the math behind it, because personally, I think that if you have an understanding of ZKPs, how ZKPs work, you will have a better chance to create a killer app on Mina or in general with ZK. On the other side, we onboard you with the protocol and its architecture. Mina is very different, and understanding these differences and how ZK snarks are used for Mina's architecture is really interesting, and it will give you a better idea of what kind of ZK apps are best to build on Mina. And we have some frameworks and infrastructure that we go through, such as O1JS, our TypeScript library that helps you build zero-knowledge applications. We help you understand ProtoKit, which is a ZK app chain framework where you can launch your own rollup with runtime models. And another interesting one is they launched recently, which is ZK Cloud Worker, where you use other people's computational power for proof generation, and of course the fungible token standard that was launched recently. In general, in developer ecosystems, you will see lack of peer-to-peer support or direction on what to build. So I've been observing this for years in different ecosystems. That's why we are making sure that you receive weekly support on your pain points and the challenges you face. So the target persona for modules are really, doesn't matter if you're coming from Web 2 as well, but we are looking for good engineers or mathematicians who are new to ZKPs, blockchains in general, or Mina protocol. So, and this program is invite only, but you're lucky to just meet us here. So if you want to join, please talk to me and we will onboard you to modules. We designed our program with a smooth transition. So actually, if you complete the modules, you can directly continue with starter track. But I'll talk about what is Navigator starter track. So a starter track is again planned for 4 to 6 weeks. And the whole goal of Starter Track is either you build a proof of concept on Mina, or like as I told you, we want to invest in good engineers, and I know like time is scarce, and we want to support you. So if you want to research more and come up with a growth proposal, so you can also join Starter Track. So you don't have to build stuff, but either you make your own deep research and come up with a proposal for the growth. The funding size is up to 15K Mina tokens based on your team size or experience with blockchains and building applications. This Navigators is really planned and scheduled for fast onboarding process. So if you want a hackathon or just get to know each other and want to start quickly, you can easily join to start a track. Okay, let's talk about our growth machine for the ecosystem, which is the growth track. And the whole goal of Navigators growth track is really to have people who build production-ready ZK apps or infrastructure in 3 months. So you can think about it as an incubation program. And the funding to proposal is up to 100K Mina tokens. And how it works is we have a Mina platform called Mina Research, and we launch your proposal on Mina Research, and there's a public refinement process where you receive feedback from technical experts and exploration teams, both from Mina Foundation and all OneLabs. So this program is not invite only, so anyone can make a proposal, and I'll show you the proposal template and what we look for in the proposals. The target persona for this program is really experienced ZK developers or the graduates from our programs, modules, and Starter Track, big dev shops, as well as O1JS experts, because O1JS is slightly different from Solidity or other Web3 like development frameworks. So we wanted to spend the time and invest our time into O1JS to get started with Growth Track. And this is the proposal template for Growth Track. So if you're interested in, let's start with from the business perspective. As you can imagine, problem is most matters if you build a product. So we wanna have you explain clearly what problem you're solving and what's going to be the impact on the user side if you build an application, or on a developer perspective if you're building infrastructure. And another side is like user research. I think is one of the biggest missing gaps in crypto today. So we want you to clearly define who is your target audience and like who will use your product in that case. As I went through, like the architecture of ZK apps and Mina is slightly different, I think in a positive way, between Web 2 and Web 3. That's why we wanted to study like the architecture and come up with feasible solution, closely working with our exploration team. So we have this exploration team who is helping you defining a feasible way to build your ideal product. And what's your vision? So what it looks like in a year or 2 years, and like what is your growth path, what is your existing work, and what is your timeline to make it production ready? I mean the application or the infra product. Last but not least, on the financial side, we want you to clearly define what are your deliverables for midpoint milestones, which is 1.5 month, and then the final milestones end of 3 months, as well as what budget you need and how you're gonna spend your budget. And this is really important because I hear lots of feedback from different ecosystems that like foundations or ecosystems give grants, but they don't follow up after giving the grant. One thing I think we are best is supporting our developers and create a safe atmosphere and culture to work with each other. So we have 24-hour support online through our ZK questions channel in Discord. So if you're already familiar with our Discord, log in, we are very active on Discord. So another one is in ZK, it's quite new for I think consumer applications, and you may heard of like ZK TLS nowadays or ZK email. But I think it's a bit hard to come up with a killer app ideas. That's why we just don't want to force you to come up with an idea, but we have a dynamic idea board that you can pick up ideas for inspiration. And the last one, as I told you, we are helping with your architecture and find you the feasible way to build with the next team, which is Navigator's exploration team, as well as thanks to O1 Labs engineers. So these were like the grant programs, and right now I want to talk about what's coming and how you can fastly start contributing Mina or try building stuff. We are sponsoring these two hackathons, EAT Singapore and EAT Bangkok, and we have a 20k USD prize pool for each hackathon. So we are inviting you to join EAT Singapore or EAT Bangkok, and you will have fun building on Mina. So, okay, I talked about grant programs, but why not waiting? You can just start today to contribute, and I'll show you a way. A team in our ecosystem just launched astromina.org. Please go search for this website. And this is an ecosystem bounty platform where builders can find bounties, work with different projects, and earn Mina tokens for contribution. So I strongly recommend you to start contributing on Astromina. That was all. I'm the guy who can talk easily, and we'll get friends, we'll get well each other. So please talk to me. I'm here all day, and these are my contact information. So, 감사합니다.
Okay, so actually, I forgot to introduce myself. So yeah, yes. My name is Logan. I'm the Korean Developer Community Manager. 안녕, 저는 로건이고요. 저는 한국의 코리아 커뮤니티 개발자 커뮤니티 매니저로 일을 하고 있고요. So if you guys interested in the awards, Mina, or if you want to apply the Navigator or some other the grant program into Mina, so please feel free to ask me, or maybe you can get my business card. So yeah, so 혹시 여러분들이 이제 미나에 있는 온보딩 프로그램이나 혹은 그랜트 프로그램 같은 것들 뭐 제출해 보실 이야기 있으시면은 저한테 연락 주시면 되고요. 뭐 사실 제가 영어로는 길게 말을 못하지만 한글 정도 설명을 드리면 이제 실제로 온보딩 프로그램을 여기 하고 계신 분들도 몇 분 오셨고요. 그분들이 오셔서 이제 실제로 영어를 잘 못하셔도 제가 통역 같은 걸 도와드려요. 그래서 여러분들이 영어를 못하더라도 내가 미나에서 뭔가 만들고 싶은 게 있다라고 하신다면 저한테 오셔서 제공을 받아가시거나 혹은 저희 텔레그램을 가져가시면 제가 이제 온보딩 하는 거를 도와드릴 예정이다. 그러니까 네, 이번에 관심 있으신 분들 오셨을 테니까 한번 저한테 좀 이따가 토킹 파티 때 이야기해 주시면 좋겠습니다. So the next part is the Zico. 죄송한데 또 이제 자리 가능하면 앞쪽으로 좀 옮겨주시면은 네, 부탁드리겠습니다. Please move your seats from the shit. Yeah, thank you. Thank you. So yeah, next is the Zico. Zico is the layer 2 on built on Mina. So yeah, Brian, please.
Hi everyone, my name is Brian. I'm from the Zeco project, and I'm here today about scaling CK apps. And fun fact for everyone, Zero Knowledge Cryptography was created in 1982, and really only now it's in the hands of you guys, and people are able to develop using this type of cryptography, and without having to do, I don't know, 12 years university and 2 PhDs and a lot of work. And so, thanks for the opportunity, and let's talk about Zeco. Who's the deck?
详细的提供。
Yay! Sorry for the technical difficulties. So, very quick takeaway. Zeco is a layer 2 for Mina, with the sole purpose of scaling ZK apps, such that developers have a better developer experience and users have a much faster UX UI experience. So we're aiming for sub 2 second settlement time, and throughput can be scaled up and down. Yeah, so Zeco adopts a fully modular approach to our stack. So there's separate components for data availability, proving, and sequencing back to the L1. And why build on Mina? Well, Mina comes with all of this heavy ZK cryptography that's been in production for 3 years now. And we kind of get this out of the box, right? So Zeco for free gets the recursion of Mina, and we can get to full ZK rollup security really fast because we don't need to re-implement and research and design a whole brand new proof system. And why did we not build an EVM layer 2? Well, we feel that ZK apps are the most differentiated way to build new products in crypto today. And the EVM is like super powerful and it's everywhere, but I don't think the world needs another EVM L2. But what it does need is the ability to create new types of behaviors and experiences for users, and using the model that Mina has implemented, where we have off-chain computation that verifies on-chain. So you get this off-chain scaling and you get privacy as well. And this is something that you don't get on any other blockchain. So we feel strongly that Mina and Zeco is the place to innovate for developers now and really differentiate on their commercial products. But also for people who are migrating from Web 2, that they don't really understand the concept of gas, right? It's like another thing that exists in their development environment. And nor do they understand that privacy is like not really possible on blockchains, and they usually want to keep privacy for their users. They do just having centralized databases, but they also want to keep privacy for themselves and their logic and their internal ledgers and everything else. So we feel both like for crypto native developers, like Zeco and Mina is a really good place to innovate, and for new to crypto developers, it's a really good place to build commercial products in a way that Web 2 people can understand, and it meets their needs. And on top of that, everybody's going to learn about O1JS today. And for Web 2 people, they can already built with TypeScript. They need to learn about like the blockchain part and some of the abstractions and everything else, but it's in a language that's familiar to them, and they don't need to relearn a brand new, basically, blockchain language. This slide is about the internet and basically the power structures within it that we have today. And basically, the big companies have 99.99% of the control of our data, and they take the same amount of revenue from us for us having the pleasure of using these services. And they're not even good custodians of this data, right? Almost every major corporation has been hacked. And so I think with ZK, and especially ZK combined with blockchains, we can start to eat back some of the power, and not only in a defensive way, but also to create opportunities for people so that they can monetize things about their lives and create new experiences and behaviors through ZK that only this kind of technology can provide. Where we can actually self-custody our own data, right? And use it in ways that benefit us. This is the team. We're growing. Many of us have experience on other blockchain projects before. I used to work at Mina, and Sebastian, our co-founder, is one of the biggest builders in the Cardano ecosystem, and now same in the Mina ecosystem. And we're hiring on marketing and ecosystem growth tracks as well. Mina Foundation O1 Labs are early backers and contributors. We did a fundraise earlier this year. Predominantly Asian investors who are on this sheet, but a good mix of European and US investors as well. So where are we now? We're in the DevNet era. So we've launched our MVP, which means the testnet is up and running. The testnet is fully compatible with O1.js. All of the tooling, so block explorers, wallets, and the developer environment is exactly the same as it is on Mina. And it's very easy to redeploy an already written ZK app from Mina onto Zecco. So now we're moving into mainnet era, so we're shooting for mainnet in early Q4 this year. And yeah, so that's where we are. We've been building for around 18 months so far. And really in preparation for the Mina hard fork and the ZK apps upgrade, because that was what was going to basically enable our infrastructure to work, to be able to settle to L1. But also now the whole O1.js ecosystem is growing, and we see that there's going to be a demand now for extra block space, basically, and extra performance. So I already mentioned the modularity part, and a lot of the features that we see here are basically overlapping with Mina. Mina is a really good place to be an L2 on top of, because it's already a very, very decentralized L1, and it already has the ZK primitives built in from the ground up. So it's actually probably the best place to be a base layer for L2s, which is really cool. And things like the privacy and the programmability, they come with the O1.js. So O1.js is fully compatible with Zecco. So the Zecco L2, the canonical Zecco L2, is basically Mina on top of Mina. And there's going to be a slide soon with the architecture. So we see L2 Zecco, which is Mina on top of Mina. Then anybody can create their own Zecco app chain. So we see many L3s, again on top of Zecco. And these can be fully customizable and tailored to your particular use case. You can set different parameters, you can have your own token, you can do different things. And when you're in the L app chain space, you don't need to, compete for block space on the L2. The chain that you're running is only for your own application, which is really cool. And you get to use all of the modular components out of the box, which we built for Zecco. So there will be an SDK coming, but the main release is L2 Zecco. So like general purpose Mina L2, where you can deploy your own JS app. And we'll be talking about ProtoKit as well later today, and it'll be possible as well to run a ProtoKit as a Zecco L3. In terms of like how it works token-wise, there will be a decentralized sequencer and that sequencer election or auction will happen on the L1, so validators will bid in Zeco tokens to get elected to be the next sequencer, and I guess gain the profit basically off the user fees that have happened on Zeco. In terms of connectors, we're working, Mina Foundation are working with LineLayer, who are building a state-proof bridge to EVM, so that application state and actually the whole state can be verified in EVM, such that an Ethereum developer can use the private parts of their whole project, I guess, using ZK apps, which is really cool. It's like an extra superpower for those big projects, and we see these people as a key area of adoption. Also, off-chain enterprise, there'll be a connector for that where people want to verify or prove things about their own internal databases without revealing what's in them. Like I think the Miri asset management use case, which we talked about today, is a good example of that. And yeah, it's basically many Minas possible on top of the original Mina, which is really cool. In terms of how we see the growth trajectory, I don't see these as linear, and they won't happen like one after the other, but like Web3 natives, so like it's important for us that the already existing Mina community gets to know about Zeco and gets to experience it. And also like EVM developers as well, it's important that they realize that how easy it is to build using ONJS, especially on Zeco. And I mentioned at the start about this Web3 tangential group, but I do feel that like ONJS is a really good place for new to Web3 developers. And like it could be argued that like the mass adoption of developers into the whole blockchain ecosystem hasn't even happened yet. So I think when a lot of these people do arrive, they're going to want to build with some privacy. They're going to like this off-chain execution part, and they're going to want to use TypeScript and not learn a new language. And the last one is Web3 Enterprise. We had this effort, must have been like 4 or 5 years ago now, about a lot of permissioned blockchains that we're running. But it really makes much more sense for enterprises to use a permissionless network but do zero-knowledge proofs over the state of their own internal databases, rather than basically building their own blockchain for each enterprise and maintaining all that infrastructure and everything else. So we think that's a really important area of exploration as well. Especially, it's something that really only ZK enables. Yeah, so this is kind of 4 tracks that we think people will want to build in, and we have partners already building in each of these tracks. And I guess not limited to all of these tracks, but we think that these things are what ONJS, Zeco, ZK are particularly useful for. And just want to give an example. We have a gaming track back here, but I just want to give an example of something that's being built right now by our partners at Pine Studios, which is a gaming house. So what Pine have done here is that like they already have a game running on Arbitrum, and they have a lot of users there, right? But they want ZK features for their game. Now, they realize that a lot of the users and a lot of the TVL and everything is on Ethereum, so a couple of things here are enabled by how powerful the cryptography on Mina is, that Mina can basically verify EVM signatures. So starting from left to right, the user enters via MetaMask, and their Mina wallet is created in the background, and the gameplay actually moves to Zeco. So it's actually it's a pretty simple game, but the gameplay is basically using ZK to roll up the gameplay. Then it's bridged back to Ethereum, and the game is kind of settled there, right? So if there's a payout that happens on ETH or whatever it may be. But for all intents and purposes here, the Ethereum user probably doesn't know that they've left Ethereum, but the game developer is able to use all the advantages of ZK for their game. Whether that be like rolling up many moves, or having like a private area or private state in a game. And so it's quite a powerful experience, I think. And this kind of like route is not just for gaming, right? So like any VM application could use the same architecture to deliver something for their project. And this is just a quote to like show that how bullish like smart people in crypto are about ZK. Vitalik said this 2 or 3 years ago, I think. So we've got 7 years left, and yeah, I would bet that he's going to be right because things are moving so fast, and 7 years is a long time. So let's see where we are. Thank you, everyone, and talk to you all during the day.
Yeah, so we'll have the break time for now until 4 p.m. So yeah, please feel free to having some our snacks or drinks. Thank you. 시작하겠습니다. Hello. Hello guys. Now we're gonna start the next session. Please take your seats. Hello. Okay. So The next session is the Evan will give some presentation about the state of the Mina ecosystem. So if you, maybe you guys want to know what is next for Mina protocol. Yeah. So Evan.
Hey everyone, so I'm Evan, I'm one of the co-founders of Mina. I'm going to give a quick overview about what Mina is, what zero knowledge proofs are, and also just talk about a little bit why it's interesting and cool. So, zero knowledge proofs, I feel like this audience is like pretty, knows what these things are, but let me just give like a brief summary, at least one way to think about them. One way basically is that they're a way to have a proof about a computation that can possibly hide the data that went into that computation and prove what the output is. This is useful because you can have the data being possibly hidden, so you can do private inputs. And it's cool because proof of the computation gives you trust in the compute. You can do a big computation and prove the results of it. So one way to think about this is you could have like some KYC data that you want to prove on chain. And you wouldn't just want to post that on chain, right? Because, well, it's going to have a lot of private data associated with it. But what instead you can do is you can make a proof that you can then post on chain about that KYC data. So that's nice because we're able to get the functionality of the KYC using it on a public blockchain while keeping it private. And it turns out this works for other use cases as well. So for example, I can have a ZK rollup that does thousands or millions of transactions, and then I can make a proof about it, put that proof on chain to prove what the ZK rollup is saying about all those transactions. Another example is the proof of concept of doing the direct assets in crypto. You can have private proofs of asset ownership. For example, you can have a airline company and you own shares in it, and you could use a proof about ownership of those shares to get access to a lounge or something like that. So based on the assets you own, you can get access to other benefits, but without having to expose the underlying private information that you're not allowed to. So all these use cases are great. So what is Mina? Mina is a general purpose way to do these kind of things. So we talked about like different identity stuff, different pieces of data, rollups, all that stuff. Mina is a general purpose solution for creating these kinds of proofs. It's a programming language and other tools so that you can make your own proofs of really anything you want. And one way to break that down is Mina being kind of 3 layers. At the top level being a circuit rating framework, so this is like the actual place that you code. The next being this development environment. This is where your code and smart contracts go to live and interact with each other. And lastly being this very powerful ZK layer 1 that has like this very deep integration with zero knowledge proofs. So the circuit rating framework for Mina is its O1.js, which you probably have used. One thing that's really cool about it is O1.js directly produces circuits. It doesn't have a VM layer in the middle. So it's very, very fast. Fast enough that it can run directly, the proofs can be created directly on users' devices on the order of 10, 20, 30 seconds. So that's really cool because it means that when your users are making proofs, the data doesn't have to go to some server somewhere to make the proofs of the data just stays on the user's device, very secure, very private. It's also all in TypeScript. So it's pretty easy to learn. It's just a TypeScript library, you maybe like npm install. It does that. It also has a pretty big developer community. There's over 100 active developers at this point. There's a Discord forum which is super active. People ask questions and people are answering them. So a lot of activity there. And it also lots of libraries that are development. A bunch of them have been released, but there's also a bunch more coming out all the time to make things easier. ZK Apps is also really cool, the development environment. It's an account-based model for one, so it's not UTXO, it's like a lot easier given that. But also, you can put ZK rollups very easily on top of Mina, and you can kind of recursively compose these. So you can put ZK rollups on ZK rollups, or proofs on proofs, which is good for like this really multi-party computation system where some places the users are making proofs, some places the infrastructure is making proofs, goes all the way back to Mina to settle the proofs. Mina also has this really cool property of being a succinct blockchain. So Mina's constantly updating a zero knowledge proof of the entire layer one, like one zero knowledge proof that says that gives the validity of all the computations since the beginning of the network, which means it's really cheap to verify the entire chain. You can take the zero knowledge proof and receive it on your phone, on your browser, wherever, and you're able to use that to be sure of what the current state of Mina is very securely without needing to download, a full node of many hundreds of gigabytes or relying on a third party for that functionality. So if we're building like a truly peer-to-peer application, it's really powerful for being able to do that in a really decentralized way. Let's go through so here's like a concrete example of everything we just talked about. I'll go through it, but at the top we have, this is kind of like the ZK circuit part of things, where you are writing your code and making your program. And that runs in a browser. That, in this example, goes to like a ZK app chain. And the ZK app chain is rolling up all the user transactions into a single proof that then settles onto the Mina 01. So each ZKP transaction in Mina 01 can be a ZK app chain, it could be a layer 2, it could be a layer 2 with ZK app chains coming off of it. It can be this kind of a hierarchical nest of computations. And then Mina itself is always making those zero knowledge proof that gets sent to browsers and phones and can be quickly checked to know the entire state of the chain all the time. So you can imagine lots of devices, it's kind of fractally settling down to like the chain, which then everyone can check and know exactly what's happening all the time to make these kinds of applications. In this actual example, we have kind of a stage of two things happening on the user's device. Stage one is kind of happening in the actual user's wallet. And in the wallet, we have private credentials being stored. This is currently a project someone's working on, is to make this kind of private credential API for wallets. And in that, we have some logic for creating a off-chain zero knowledge proof that says, I own a credential, and that credential is from the issuer that we expect it to be from. If I hash all the things in that credential, that hash has actually been signed by the by the issuer. So you know that this credential that has your public key, your name, your address, a bunch of other information, actually has been signed by the issuer. And also we have here a proof that our private, that we actually own the private key behind the public key in the credential. So between all that, we can kind of output a proof that we own this credential, the credential is valid, and so on. So that's stage one, and that's all happening inside of this wallet extension, inside of your wallet. So nothing is leaked to the browser or the external world. The only thing that actually leaks this extension is this proof itself. It doesn't have any other personal information associated with it. But then what you can do is you can feed that into a ZKP transaction constructed for an application inside the browser. So the first step being you could verify the ZKP KYC credential. And then you could do something now that you know that's true. For example, now that you know it's checked, you could do a DEX transaction on some special KYC DEX. You could do a vote in a special DAO. You could do an airdrop to users that have that property, etc. And you can imagine you have a lot of different credentials, and you can use those to kind of permission a lot of activities on chain, like KYCing or one person, one vote, or I've been in a community a long time, all that kind of stuff. You can do. Yeah. So all this stuff has just been very recently released on Mina in the last 2 or 3 months or so. For example, the token standard was just released about a week ago now. And there's lots of new libraries and apps coming out weekly. There'll be a DEX soon. There's lots of things that are being developed. And there's a pretty active developer community starting to try to grow this, the possibilities with all this new technology. And as the foundation, you already heard from Austin, you already heard from Brian and Philip. Our goal is we're trying to just help people launch their products, help make the development environment really, really good for all this stuff, because it's very, very new, all the zero knowledge proof stuff. So we're still trying to make sure it's a really good experience to use. I think it's a small group, maybe no one here, but there's David, who's somewhere out here, right here, who's our talk to him for any integrations projects. He's our head of Asia Pacific. And then also you heard from Yasin about some of our grant programs. net navigators. I would really, I think most people here have already done some stuff, but docsminaprotocol.com is a good place to start and understand more about, there's lots of other projects also that like we both like think are cool, like lots of things people are working on that they're also looking for support with. So you can talk to Yasin for any of those who's over here. If you think of any projects you want to try with zero knowledge proofs. And so that's it, just like a high level overview of the project. Zero knowledge proofs, it's all very new. I think we're still like the first ones to have in production and a lot of this new stuff. And yeah, we're excited to try to get real use cases out there and people using this technology. Thanks.
Okay. So next session is Brandon give us let us know about the future of Mina protocol.
Okay. Okay, great. Hello, can you hear me? Okay. All right. Hi, I'm Brandon. I am the CEO of OM Labs. We incubated Mina protocol, and the Mina Foundation spun out of OM Labs, and we still do a lot of stuff with it. So I'm going to talk about the future of Mina. A future of Mina. Mina is a decentralized protocol, and so I don't get to say what it is, but I'll say what what some stuff we've been thinking about, and hopefully like the community and everyone will support it and be excited about it. So this is a sneak preview. I put this together on my flight yesterday. A lot of stuff is actively being discussed and figured out. So it's like you're getting it first. Okay, so let's talk about the internet. There we go. The internet started in the 70s, I think. And when it started, it was a place where information could easily be shared and accessed around the world. This is like HTTP, But the internet today that we're using, like the Web 2 internet, that really only came about through fixed function cryptography, and that's like HTTPS, right? That's the green padlock when you're using a web browser, and it's the combination of this like infrastructure that connects a bunch of computers around the world with cryptography, with fixed function cryptography in the case of the HTTPS, that enables the internet that we use today with social networks and banking and all this stuff. Well, that's fixed function cryptography. It turns out there's this new thing called programmable cryptography. We think that programmable cryptography will really enable like a new wave of innovation. And this like flexible cryptography can be programmed. So instead of just being fixed to secure a connection, you can make it do whatever you want. And obviously, we've been talking a lot about ZK. That's a really good thing to use as your core for this new like internet of programmable cryptography. We've talked about ZK proofs a million times today, but I'm going to talk about them more. why are they interesting? They're private. They enable privacy. So ZKPs don't reveal information by default. You can make them reveal as much information as you want. They also provide a trusted execution environment, and that's not like TEE, like the TEE chips that keep getting broken every month, but like it's a way that you can execute something, and the steps of the computation are sort of fixed ahead of time, and you can trust that those same steps were executed no matter where the proof was created. So that's kind of interesting. They produce small certificates, so you can run a big computation, you can do a bunch of stuff, but what you get out is this tiny small thing at the end. And it doesn't matter how big the program is. And they're self-composable. And that is that you can take the results of one ZK proof computation and combine them with another one, and combine all these things into more proofs, and that's sort of at the heart of Mina, as we all know. So, yeah, so why do we care? Well, when you leverage ZK proofs, you can create applications that do interesting things, like ensure data authenticity. You can detect manipulation attempts, and protect users. So Mina, we talked about that a lot. Mina, pioneered the use of ZK proofs in its protocol. When we launched it a few years ago, it was the first sort of instantiation of something using recursive proofs in production, and now with our new release, it's the first general purpose programmable ZK system in production. And there's lots of other interesting ZK projects coming out that let you build ZK proofs in different ways, and they all contribute to this like new internet. And actually, there was an article that was posted just 2 weeks ago, I think. That's like totally independent of our thinking, exploring this like HTTPC idea. There's an article about using programmable cryptography to kind of generate a new like just-in-time internet where you can do interesting stuff. So you can hallucinate servers, which sort of means that you can run things off-chain and run things on your own computer, do things privately. You can for example, great. Okay, so that's a second. You can adapt it to any kind of cryptographic data. So you can take data from websites, from databases, from your passport, your ID, things from government databases, and sort of combine them all together. And you can do cool stuff. So you can have personalized recommendations without leaking your personal information. You can create social networks where you're permissioned in based on a credential, like similar to the system that Evan was just talking about. You can have, you can even imagine a world where like you're notified about a disease because you've created a proof of your kind of genetic condition and like some of your health data, but no one will have that secret information about your genome. Obviously, you don't want that. So all this stuff is cool, and actually, there's a lot of different ZK technologies that are popping up. Mina is the most advanced and is the one that I'm really excited about. But even with all these other systems, there's a big piece of the infrastructure that's missing from all of these things, except for Mina, which is the actual protocol by which this information can get delivered. So, you need a decentralized, censorship-resistant platform where these proofs can be accessed and built upon. Kind of in Evan's last presentation, it was that he had some, there there was something on the side, and at the bottom there was like, okay, the proofs can go to like a phone and a web browser and all that stuff. That part. This is really important for an internet. Like, you need a way to access the things that you're proving. So, there's some work to do, but like, I'm really excited, and like we're all really excited about like that being Mina. Like Mina is this internet for ZK. Like I said, it's decentralized, it's censorship resistant. Mina actually has always kept scalability and decentralization in its like purest forms, and never compromised on that. And because of that, like performance is not as great as it could be, and we're working on that now. But like, it's because we're never compromising scalability and decentralization. It's portable, so a few folks alluded to this today, but there's a project that's like super close to launching called Open Mina, which is a full implementation of a node that you can run from the browser. And so you can operate a node using it, but the cool thing is you can actually access DApps without an RPC because you can just run a node on the page of the application. And it's ZK native. Mina itself, obviously, did we even talk about this today yet? I don't know. But Mina is one big proof that's constantly updated. Okay, and obviously because of that, we can, and especially after this new upgrade, we can tap into this and sort of do interesting, programming with it. And we heard about that already. We're going to hear more about it later, so I'm not going to go too deep. So I'll say though, like, for all these reasons, like Mina is this place where HTTPZ can live. And so again, like the future of Mina, it's determined by everyone, not me or not OM Labs, but from the perspective of OM Labs, we envision an internet where developers will use programmable cryptography to create more powerful applications, and that internet needs Mina, like because Mina's at the core. So where are we now? Mina's been on mainnet for a while. It's been stable. There's no unexpected outages since mainnet, which I'm really happy about. I guess I forgot to say this. I was, an engineer for a while. I'm only recently a CEO. So having worked on it, I'm happy that it's not broken. And as I said, it's the only, as of June 4th, when the ZK app upgrade launched, it's the only general purpose ZK programmable platform in production. So all these ZK rollups and things like that are starting to come out, like those are just EVMs that are fast, which is cool, but different. You can't actually program like custom ZK stuff. And this is the first step towards this new internet. Next few steps. Okay, so as I was saying earlier, like, look, we have on Mina right now, I think the best platform for building ZK applications. ONJS is amazing. We have other tools that people are building, like ProtoKit and L2s like Zecco. But there are lots of tools, and there's lots of tools that are good at different things and different purposes. And so it's important for any like HTTPZ system, any internet, to be able to support lots of different proof systems. And so building these adapters to get proofs from other proof systems and other platforms into Mina is super important, and it's something that is already starting. So this is public information. I don't think it's announced anywhere loudly, but there's open source stuff, so I don't think I'm leaking anything. But there's a project by Geometry Labs. They're working on adding Celestia support to Mina. And they're really close. And actually, as part of that, Celestia uses a couple different ZK proof systems to kind of prove its data availability stuff. So because of that, all these proof systems are now supported in Mina as well. There's O1 Labs. We're going to help launch mainnet applications as well. That's something we've heard from a lot of people. We want more applications. There's a lot of devs, and everyone's doing cool stuff. Performance, stability, and then we can always improve the SDK. So yeah, I mean it's really really early thinking here. I hope I made sense, but I think there's a really cool opportunity to build an internet of truth, an internet of truth things, an internet where we have programmable cryptography at the core, not just fixed function cryptography. And the research and tooling is finally getting to the place where we can do this, and Mina will be at the heart of this system. So that's my thing.
And last with Brandon's presentation, I think this was more of a general overview of Mina protocol and Mina ecosystem. And now I think we're going to go one step deeper with Luke giving a more in-depth seminar on how to program ZK apps on through O1JS. 다음은 이제 저희 그 커뮤니티 멤버인 루크가 이제 저희가 좀 추상적으로 설명했던 이 전체적인 미나 프로토콜 이후에 좀 더 이제 GK 앱을 실제로 프로그램할 수 있는 내용에 대해서 세미나를 진행하는 거예요. 네. 그러면 저희가 이 세미나 하기 전에 저희 행사 이벤트였던 추첨을 진행하도록 하겠습니다. Luke?
Yeah, so this page is the lucky draw is one of the traditional way to choose who gives some presentation. But for today, we will use this as some level tools. So. So yeah, the next number is 46. So yeah, for example, it just we put select this button, the written Korean is launch. Yeah, you can see that the number will like this. Yeah, so. Evan, could you please put this button? So, yeah. So,
All right. Yeah, we'll see who the winner will be.
Yeah. Oh, 37. Do you have 37? Okay. No one.
If you're 37, you win. How do you know what number?
Yeah. The raffle ticket you have. You get when you entrance this event, there are some little small tickets, and then the right side you can check your numbers. So no one has 37. Yeah. Okay, so could you
Okay.
one more?
I just push it again.
Yeah. Yeah, 12. Yeah, maybe. Maybe. Oh, yeah, yeah.
Oh, yes.
You got this.
Look at it.
We are hosting this and I'm the member of the team, so I want to lead the present.
Ah, yeah.
Okay, so one more. Okay, we're going again.
Yeah. One more? Yeah. No, oh, that's 7.
7.
Do you have 7? Yeah. One more time.
3, 2, 1.
Yeah. 5.
5.
Where? Okay. Yeah, okay, so one more time. 45? 45, maybe. Maybe. Okay, one more.
This is ZK1. ZK. No one knows his number.
Okay, yeah, interesting. More. 46. No. No, maybe, yeah. Yeah. 32.
32.
32.
I think 5
33. No. 10. Yeah!
Number 10.
Over 10. It's more suspense.
Yeah.
He's also sponsored.
Yeah. Right. Yeah, number 10. Okay, so we checked. Yeah, so.
Bravo!
Thanks for iPad for Mina Foundation. I'm Hwang Jae. I'm Mina validator from the DSLV. Yeah. I always support Mina. Thank you.
Okay, thank you. So. Yeah, so the next session is. Okay. Please make sure time for this. Okay, so we need more time to prepare this. So yeah, please, since now we have the break time for 15 minutes. We will start at 4:50 p.m. Thank you. X리의 아들이에요. 얘만 나오면 괜찮으니까. 한쪽에 나오면 돼요. 맞아요. 한쪽에만 나오게 하면 돼요.
How are you?
구글릿 같은 걸로 저는 컨트롤하고 얘도 그냥 화면으로 하는 걸로 할까요? 하나 뻗어가지고
That's like, that's it.
will give you some hands-on tutorial session about O1JS and ProtoKit. So yeah, please. Thank you.
안녕하세요. I'll start presentation this one and with some quote. 그래서 이제 미나랑 이더리움의 차이점은 뭐죠? 그래서 제가 생각하기에 가장 큰 차이점은 블록 구성 요소도 차이가 있고, 어쨌든 그 스마트 컨트랙트 메커니즘에도 차이가 있다고 생각해요. 그래서 일단 블록의 주된 구성 요소가 GK 스나크라는 점이랑, 그리고 GK의 구동, 그러니까 스마트 컨트랙트 구동 원리가 이제 로컬에서 유저가 GK 스나프를 생성한 다음에 그거를 온체인에 올리는 거죠. 그래서 근데 이거는 길게 설명 안 했어요. 그래서 프로바블 프로그램의 예시를 하나 들고 왔는데, so the example is mini POW game, and you can see in this page. Wait a minute. Okay. So how this works? 제가 이 문제를 내놨는데 맞추면 천재입니다. 그래서 아무튼 여기서 이 자연수를 넣어서 이렇게 개수를 누르면 이제 이런 식으로 딱 나와요. 사인 리퀘스트. 그래서 여기서 로컬에서 GK 스나크를 만들 겁니다. 그래서 근데 이건 아니에요. 이거는 제가 다른 더미 트랜잭션이고, 이게 메인 트랜잭션입니다. 그래서 이거를 만들어서 보내면 이제 온체인에 있는 컨트랙트가 이게 답이 맞는지 확인을 하는 거예요. 그래서 이게 코드가 이런데, brief explanation of POW game, and I guess this cannot be implemented by on Ethereum because 그래서 왜 이더리움으로는 이런 메커니즘이 구현이 안 되냐면, 그 로컬에서 스나크를 만들 때 이제 그 통과가 돼야지 스나크가 만들어지는데, 이게 통과가 안 돼가지고 결국에는 만약에 이거는 이더리움에서 하려면 무한번 시도하면 가스바움이 생깁니다. 이거는 무한번 시도를 허락을 하는데 맞을 때만 트랜잭션이 나간다고 보면 돼요. 그래서 이거는 나중에 같이 구현을 할 겁니다. 네, 그렇습니다. 그리고 another example, probable program의 another example은 CK extension인데 뭐 이렇게 있어요. 그래서 만약에 GitHub을 갖다 치면 그 GitHub 같다고 증명을 하는 거예요. 근데 이거는 지금 같이 상호작용하는 DL이 있어야 돼서 이거는 있긴 한데 여기서 보여주긴 너무 시간이 오래 걸릴 것 같아서, 아무튼 probable 프로그램의 example 중에 하나는 SDK 익스텐션이고 이거는 이 웹워커 이쪽에서 OJS를 통해서 만듭니다. 그리고 왜 이렇게 웹워커를 빼냐면 그 프롬 익스텐션 정책 중에 wasm이랑 이벌 쓰지 말라는 정책 때문에 이게 이렇게 백그라운드 스레드로 빼서 이렇게 해야 되고요. 여기서 뭔가 트래킹해서 리퀘스트를 받으면 여기다가 샌드를 합니다. 그래서 여기서 최종적으로 그 만들어진 GKP를 디앱으로 토스해서 이렇게 쉽게 쓸 수 있게 하는 거예요. 그래서 CK 스나크를 설명을 막 하기보다는 그런 코딩을 그냥 빠르게 하는 게 나을 것 같다고 생각해서 빠르게 했습니다. 그래서 OneJS의 장점에 대해서 얘기해보자면 만약에 뭐 썰컴 같은 걸로 이렇게 프로그래머 프로그램을 짜려고 하면 엄청난 수고가 들어요. 되게 앱스트랙션 된 OneJS를 써서 좀 쉽게 만들 수 있습니다. 그리고 OneJS는 그 달리 막 엄청나게 복잡한 가정도 필요 없고 OneJS 라이브러리에서는 아주 많은 크립토그래픽 프리미티브스가 있어서 안에서 프라이버시 유지하는데도 굉장히 유용하게 쓸 수 있어요. 그리고 뭐 서킷 안에서 ECDSA 시그니처를 베리파이 한다든가 그런 류의 오퍼레이션도 가능합니다. 그래서 네, 아주 간단해요. 만약에 이 스마트 컨트랙트를 썰컴으로 짠다면 아주 힘들어지겠죠. 그리고 OneJS에는 스마트 컨트랙트랑 GK 프로그램이라는 두 가지 템플릿이 있는데 OneJS랑 GK 프로그램의 차이점은 GK 프로그램은 스마트 컨트랙트처럼 온체인 스테이트 이런 거랑은 전혀 관련이 없습니다. 대신에 이거의 메소드 오퍼레이션의 리솔트가 결국엔 GK 프로프를 생성한다는 점에서 좀 더 유용하고 좀 더 플렉시블하게 쓸 수 있어요. 근데 얘는 스마트 컨트랙트는 온체인에 올라가서 결국에는 이 스마트 컨트랙트를 배포를 해야 되는데 배포를 하면은 베리파이어가 아니라 이제 그 프루버가 아니라 베리파이어가 올라가요. 베리피케이션 키라는 게 올라가서 쉽게 증명할 수 있어요. 그래서 기본적으로 이제 메소드의 리소스가 제대로 이렇게 반환이 됐다는 건 assert statements가 다 맞게 나왔다는 뜻이 그래서 뭐 여기 뭐 assert equal 이런 게 다 맞았다 라는 증명을 제출합니다. GK 프로그램도 비슷한 식으로 해요. 네. 이제 아까 앞서 말씀드렸다시피 이렇게 dependency for chain이 difference다. 그게 중요한 차이점입니다. GK의 빌드를 할 때 조금 일반적인 프로그래밍 할 때랑 좀 다른 게 있는데 deterministic circuit for proving이어서 그래서 뭐 막 런타임 메소드나 막 사이드 이펙트가 많은 그런 프로그래밍을 할 수 있습니다. 네, 그래서 만약에 일단 회로가 GK 회로 호환되는 그런 변수들이랑 리턴 값이랑 어설트랑 그런 게 다 있어야 되고 그래서 결론 말하자면 no side effect예요. 그 사이드 이펙트가 있으면 안 돼요. 그래서 전부 다 결정론적인 서킷 로직을 구현을 해야 되고, 뭐 미나의 스마트 컨트랙트는 온체인 스테이트를 256바이트까지 지원합니다. 대신에 이제 오프체인 스토리지랑 GK 프로그램을 이용해서 오프체인 스토리지랑 인터랙션을 할 수 있어요. 그래서 필드에 의해서 일단 정의가 되는데, 필드는 너무 알제브릭한 컨셉이기 때문에 일단은 이런 너무 같아요. 그래서 일단 바로 튜토리얼 들어가는 게 좋다고 생각합니다. 그러니까 POW 게임을 구현을 하려고 하는데, 그러면 이렇게 두 가지 메서드가 들어가야 되고, 네. 그래서 일단 바로 블루로 들어가 보시죠. GK앱 CLI랑 전부 다 세상 세팅을 해야 되는데, 저는 이미 해서 일단은 저거 따라오시면 될 것 같아요. 이제 GK앱 위해서는 이제 이 모든 그 스마트 컨트랙트나 이제 GK 필드가 엑스포트 형식으로 그렇게 구현을 해야 돼서 일단 엑스포트를 붙여야 돼요.
너무 안 보이는데 확대 한번 해주시겠어요? 네. 화면 플러스.
그래서 간단한 설명을 하자면, 여기는 미나 온체인 스테이트를 저장하는 공간을 지금 만들고 있어요. 그래서 저 어노테이션 붙여야 되고, 또 타입 지정을 하고 이렇게 해야 됩니다. 그래서 제가 지금 아까 말씀드린 이 POW 퀴즈를 만들기 위해서 이 온체인 스테이트를 해야 되고, was can be called once여서 그래서 플래그를 설정을 하려고 해요. 그래서 이게 불리언 타입이긴 한데, 이게 O1JS에서 필드로 구현된 필드 컴패티블 불리언 타입이어서 이게 그냥 불리언 타입이랑 좀 다릅니다. 디폴트는 false로 줄 거고, 그래서 이제 set answer 할 때 set answer를 한번 call 하면은 그 set answer의 마지막에 이 플래그가 true가 되게 만들면서 set answer 딱 한 번밖에 못하게 이렇게 만든 거예요. 그래서 일단은 이 answer는 일단 디폴트는 값이 0이고요. 이제는 set answer을 교환할 건데, set answer 함수가 어떤 걸 하냐면, 그리고 이 온체인 스테이트를 체크를 해야 되는데요. 이거를 그러려면 일단 한번 이 온체인 스테이트를 get을 한 다음에 require해서 맞는지 한번 확인해야 돼요. 그래서 네. 그리고 privacy preserving 때문에 아까 말했던 cryptographic primitives 중 하나의 포세이돈 해시, CK 프렌들리한 포세이돈 해시를 통해서 답을 난독화를 시킬 거예요. 까먹어서 잠시만요. 아까 가져온다고 했는데 가져올 때 조금 이렇게 검사를 해서 가져와야 되고, 일단 플래그를 가져와서 이게 일단 false인지 확인을 하고, 그 다음에 딱 로직으로 들어간 다음에 그 다음에 true로 반환해서 딱 한 번밖에 true 못하는 로직을 지금 짤 거예요. 그래서 이런 식으로 하면은 이제 온체인 스테이트를 제대로 가져갔다는 되고, 그다음에 이제는 온체인 스테이트를 짤 수 있어요. 쓸 수 있어요. 그래서 false인지 확인을 하면, 이게 만약에 반환이 되면 이게 false라는 게 자동으로 증명이 된 겁니다. 지금 너무 필드는 솔트인데, 일단 이거는 설명 생략하고 솔트를 맞춰야 그냥 해시를 하면 같은 값이 나오는 거예요. 이러면은 답이 난독화돼서 세팅이 돼요. 그리고 이제 마지막으로 할 거는 이 플래그를 true로 변환을 해놓는 거예요. 그러면 이거를 한 번밖에 못하겠죠. 그리고 이번에는 게스 메서드가, 게스링 메서드는 이렇게 체크, 인풋 체크를 이제 하는 건데, 이제 그렇게 해서 이퀴벌런트한테 보는 겁니다. 이 엔서 해시의 값이랑 이퀴벌런트를 가지고 보는 거예요. 이거를 엔서를 가져와서 또 assert equal을 하려면 또 이렇게 두 부가 작업이 필요해요. 그래서 에서랑 이 게스를 해시한 거랑 같은 제품입니다. 만약에 어설트 이퀄 이트 맞으면 맞는 조건이면 뭔가 패스를 하는 거고 아니면은 리젝을 합니다. 그래서 네, 이런 식으로 작동을 하고 이러면 이제 네, 정상 작동을 할 거예요. 그래서 미리 준비된 테스트를 좀 해봐야겠다. 테스트 코드고 써도 이름이 안 나가서 이거를 했을 때 테스트가 다 노드 버전이 안 맞는 것 같아요. 이렇게 떠있는데 네, 다 패스가 된 걸 볼 수 있습니다. 그래서 지금 테스트를 뭔 테스트를 했냐면 네, 이거는 세팅 앤서를 여러 번 해도 되는가 이제 만약에 여러 번 했는데 이제 개수를 딴 거를 하면 아예 트랜잭션 타임에서 리젝트가 됩니다. 이 경우에는. 그래서 예시를 보여드리면 이 12 앤서인데요. 근데 만약에 11을 넣으면 11을 넣으면 아예 트랜잭션이 안 날아가는 걸 볼 수 있어요. 그래서 이제 이게 좀 다른 점이게 만약에 GK 프루프가 다르면 그 정답이랑 다르면 아예 트랜잭션이 안 날아가요. 그래서 가스밤을 맞을 필요도 없어요. 그런 식으로 많은 플레이가 가능하다고 저는 생각합니다. 그래서 네, 여기서 제가 봤고요. 이거는 디플로이 해놨으니까 그냥 가서 봐도 되는데 좀 로딩이 오래 걸려서 저는 프로토킷을 볼 차례예요. 그래서 저는 이 프로토킷 굉장히 괜찮다고 생각하는데 굉장히 빨라요. 그래서 패스트 하다는 점에서 좀 장점이 있고 미나 블록 타임이 상금인데 그것보다 훨씬 빨라서 좀 더 비즈니스 로직 입장에서 더 깔끔한 처리가 가능하지 않나 그렇게 생각합니다. 그래서 이게 프로토킷의 작동 원리인데 그래서 일단은 여기서 사인이 사인만 하고 프루브 제너레이션은 이 시퀀서에서 프루빙 파이프라인을 통해서 패러럴 프루빙을 해서 좀 더 빠르다고 생각해요. 그리고 유저 사이드에서 좀 부담을 줄여주는 게 유저 사이드에서 프루프를 생성하진 않아요. 그래서 좀 더 유저 익스피리언스 면에서 좀 더 좋다라고 생각합니다. 네. 이게 그냥 GK 롤업이랑은 좀 다른 게 여기는 트랜잭션 배치를 아직 하진 않아요. 그냥 밸리디움이라고 볼 수 있어요. 그래서 결국에는 블록 프루프는 어떤 식으로 해야 되는지 제가 여기 적어놨는데 런타임 프루프랑 스테이트 프루프 두 개를 쓰는 거예요. 그래서 런타임 프루프들이 모여가지고 이 스테이트 프루프가 되냐, 런타임 프루프를 전부 다 썼냐라는 걸 검증을 또 따로 합니다. 그래서 이렇게 트랜잭션 리플레이도 하고 이렇게 해서 프루프를 생성하는 거예요. 그래서 그러면은 이제 스마트 컨트랙트 미나 이거랑 뭐가 차이점이 있냐? 그 경우에는 이제 만약에 그러면 여기서 사인하고 그냥 보내는 거잖아요. 그러면 프라이버시 프리저빙이 안 된다고도 볼 수 있어요. 근데 그걸 어떤 식으로 해결하면 되냐? 그거는 GK 프로그램의 프루프를 얼규먼트로 받아가지고 그걸 해결하면 이런 식으로 뭐 에어드랍프를 여기서 받아서 처리하는 거고, 그러면은 이제 에어드랍프라는 GK 프로그램 쪽에서 좀 프루프를 생성하도록 유도를 하고 그 프루프를 이쪽에 받아서 베리파이 하도록 하는 서킷이 아까 제가 많은 크립토그래픽 프리미티브스 덕분에 가능하다고 했는데 그게 이쪽에서 나오는 겁니다. 원타임 모듈이 프루프를 핸들링할 수 있어요. 그래서 그런 점에서 훌륭하다고 볼 수 있어요. 그렇게 GK 프로그램이랑 상호작용하면서 프라이버시 프리저빙을 할 수 있어요. 프로토킷에서 이제 롤업을 쓰는데 정확히 말하면 뭐 약간 오프체인 스토리지를 쓴다고 생각하면 되는데 그거를 어떤 식으로 하냐면 머플트리 싱글 머플트리를 단일 머플트리 통해서 이렇게 하고 그 오프체인 스토리지의 형태가 그렇고 그래서 멀티플한 런타임 모듈이 싱글 오프체인 스토리지를 쉐어합니다. 시퀀서 그래서 결국에는 그 런타임 모듈끼리 상호작용하려면 또 막 안에 인젝트를 넣고 그러는데 그거는 또 이제 디벨로퍼가 고려를 해서 이 런타임 모듈 안에 다른 접근이 가능할 수 있게 해야 하는지 그런 거는 조심해서 해야 된다고 생각해요. 그리고 이런 식으로 프로토킷이랑 클라이언트랑 이렇게 인터랙트합니다. 여기서 보시면 여기 뭐 트랜지션에 날린 곳이 있는데 좀 더 좋은 미나랑 좀 차이가 있다고 생각하는 부분은 이쪽에서는 샘버에 정말 쉽게 접근할 수 있어요. 트랜잭션 누가 날리냐 이거를 카운트 단에서 그걸 적용하면 가능합니다. 프로토킷을 시작하기 전에 토커를 먼저 깔아야 되는데 인스톨 토커 일단 그리고 Node.js는 버전 18 버전을 써야 되고 여기에 명사가 나와요. 일단 제가 보여드릴게요. 저는 일단 받아놨는데 일단 그래서 어떤 식으로 돌아가냐면 이게 여기서 데브 체인 이렇게 돼 있는데 일단 그 전에 빌드를 해야 되고요. 빌드 체인을 하고 나서 이게 사실 체인이라고 돼 있는데 이거는 시퀀서라고 보면 될 것 같습니다. 그래서 시퀀서를 지금 돌리려고 하고 그래서 이렇게 시퀀서를 돌려보면 지금 여기 프로듀스드 블록이라는 게 뜨는데 이게 지금 시퀀서에서 블록을 생성하고 있다는 뜻이에요. 지금은 아무런 일단 로컬 일단 제 도커 GraphQL을 대상으로 돌리는 블록체인이라서 이거 지금 트랜잭션 하나도 없는데 만약에 이제 제가 이렇게 웹까지 돌려서 그리고 이런 식으로 메시지를 보내면 여기 트랜잭션이 떴다고 뜹니다. 멤플에 트랜잭션이 떠서 지금 이 제가 사인한 게 날아가서 프로빙 파이프라인으로까지 들어간 다음에 블록이 생성될 거예요. 지금 이게 이걸 이렇게 떴고 그래서 원래 예시가 이게 아니기 때문에 그 제가 어떻게 커스터마이즈드 된 원타임 모듈을 만드는지 설명하겠습니다. 그래서 원타임 모듈이 그냥 사실 쉽게 생각하면 뭐 비즈니스 로직을 처리하는 부분이고 스마트 컨트랙트랑 비슷한 기능을 한다고 보면 될 것 같은데요. 그러려면 이제 파일 분류상 원타임 모듈을 패키지스에 가서 체인에 가서 소스에 가서 런타임 이쪽에다가 딱 표현을 해야 돼요. 그래서 뭐 그런 하는 걸 그렇게 일단 런타임 모듈을 표현해야 되는데 이제 이거는 미나랑 조금 차이점이 그러니까 스테이트 그러니까 미나 스마트 컨트랙트에서 온체인 스테이트가 256바이트까지 리미티드 되어 있다 치면 프로토킷은 사실 그 오프체인 스토리지는 자기 원하는 대로 할 수 있어서 무한대라고 생각하시면 돼요. 그래서 뭐 그냥 그 스테이트 맵을 활용할 수도 있고 여기 보시는 것처럼 그래서 그렇게 할 수 있습니다. 일단은 저는 이 메시지 구조체를 먼저 만든다고 했거든요. 여기서 미나 필드 스트럭트를 익스텐드한 메시지 구조체입니다. 식으로 그렇게 하는데 여기도 마찬가지로 OneJS 파워된 그 런타임 모듈이기 때문에 전부 다 필드 베이스드, 필드 와이즈된 구조체나 그런 걸 스테이트 인풋으로 써야 돼요. 그래서 이런 식으로 정의한 거고, 런타임 모듈도 미나 있는 컨트랙트랑 GK 프로그램이랑 비슷하게 어노테이션 같은 걸 정의해서 만들어요. 여기서 런타임 모듈 일단 정리해서 이 안에는 컨피그라는 게 들어가요. 컨피그라는 게 들어가야 되는데, 그래서 밸런스 컨피그라고 되는 건 초기 설정이에요. 근데 제가 만든 채팅 클래스에서는 설정이 필요가 없어가지고, 그래서 레코드 스트링 보이겠는데 이거는 블랭크 객체를 타입스크립트에서 표현하는 방법이라서 이게 뜻하는 건 no config라고 생각하시면 될 것 같습니다. 어떤 식으로 메시지가 나가갈 거냐면 여기 크리에이티브 메시지 오더를 정의를 하기 위해서 크리에이티브 에지 from이랑 to가 이제 센더랑 리시버의 어드레스 뭐 컨텐츠는 서킷 스트링으로 표현됩니다. 여기서는 스트링을 쓸 수가 없어요. 그리고 인덱스는 메시지를 리트리브 할 때 쓸 스테이트, 메시지 리트리브 할 카운터라고 보시면 돼요. 이걸 잠시 까보면 더 있습니다. 일단 이 더미 데이터를 긁어 올 건데, 일단 메시지를 리트리브 할 때 만약에 오류가 생기면 더미 데이터를 가져올 거예요. 여기 스테이트 맵이랑 자구조를 쓸 수 있고요. 이거는 미나에서 256바이트로 제한되었던 막 그런 것 때문에 제대로 못 썼는데 스테이트를 여기서는 좀 만들어 쓸 수 있어요. 그래서 이거는 사실 오프체인 스토리지긴 한데 워크트리랑 GK 스나크를 통해가지고 좀 개런티 되는 그런 자유 구조인 거죠. 그래서 스테이트 맵은 그냥 맵핑 자유구조랑 똑같으니까 키 밸류 이런 식으로 되는 거예요. 이제 런타임 메소드를 정리할 건데, 프로토킷에서는 런타임 메소드랑 그냥 메소드 두 가지 종류가 있어요. 원타임 메소드는 약간 스마트 컨트랙트 로직이라고 보면 되고, 원타임 메소드가 아닌 것들은 그냥 이 프로토킷 그 생성과는 아예 걸려놓는 그런 약간 뷰 펑션 같은 것들이 가능하다고 볼 수 있어요. 그래서 원타임 메소드에서는 뭐냐면 이제 샌드 메시지랑 그리고 get 메시지 그 둘을 받을 겁니다. 네, get 메시지 그 원타임 모듈로 하는 이유는 그냥 거기서 이 온체인과 상호작용을 할 부분이 필요하기 때문입니다. 그래서 샌드 메시지에서는 컨텐츠랑 뭐 보낼 사람들을 가지고 외계 변수를 쓸 거고 대충 하는 거고. 그래서 이 네트워크 블록파이트를 통해서 프리티셋을 캐치를 할 거고, 수험은 또 이제 좀 다른 식으로 잡고, 여기서 물론 이것도 미나에서는 가능합니다. 그래서 디스턴 트랜잭션.샌더.점 분류해가지고 그렇게 보낸 사람의 어드레스를 쓸 거예요. 그러면 이거 메시지는 일단 완성했고 이제 생성이 됐으니까 이제 스테이트의 메시지 리스트를 업데이트 할 겁니다. 그러기 위해서는 이제 현재 인덱스를 가져와야 될 거예요. 그러면 이것도 O1JS 파워된 코드이기 때문에 아까랑 비슷한 식으로 가져오고, 만약에 인덱스 설정이 안 됐다면 시작 인덱스, 스타트 인덱스 1로 설정하면 되고, 그리고 이 인덱스를 메시지 리스트에다가 동원시킨 건데, 이게 맵핑 자료 구조기 때문에 인덱스랑 메시지 둘 다 인클루드 돼야 됩니다. 그래서 이런 식으로 하면 메시지 보내기에 성공했다. 그런 정도가 될 거고요. 그리고 이거는 메시지를 가져오고 가보도록 하겠습니다. 그러면 이제 여기 스테이트 오프체인 스토리지의 스테이트는 메시지 리스트에서 접근을 해서 가져와야겠죠. 근데 여기서 좀 달리 여기서는 리턴도 그냥 해서 가져오면 돼서 바로 보여드리도록 하겠습니다. 전에 제가 메시지가 없으면 터미네이터를 보여줄 거라고 했는데 이게 일단 제 어드레스여서 네. 터미네이터는 제 어드레스로 터미네이터를 만들고 이런 식으로 더미 데이터를 만들고 일단 그리고 메시지에서 리스트에서 캡 이거는 말씀드렸다시피 메소드 그 메시지 리스트가 몇 별로조에서 키로 파인드를 해야 돼요. 키로 서치를 해야 돼요. 그래서 이런 식으로 하고 만약에 아무것도 없다 그러면 도미 데이터를 가지고 이런 식으로 하면 작동을 하게 됩니다. 사실 이거는 작동을 보여드리려면 좀 많은 컴포넌트들이 필요했고 미리 이렇게 제가 배포를 해놨어요. 그래서 지금 이거랑 완전히 똑같은 로직이 여기서 돌아가고 있는 거고 이런 식으로 셋을 하면 제 메시지가 그냥 이렇게 반영이 되는 겁니다. 그래서 네. 그래서 이거에 제가 받은 메시지인데 그러면은 여기서는 어떻게 참조를 하냐 여기 2가 있으니까 여기서 인덱스를 전부 쓰면서 2가 제 어드레스랑 일치하는 그런 코레스폰딩한 메시지들만 딱 다 가져오는 거예요. 그래서 일단은 그렇고 그래서 제가 이거를 적용을 하면은 여기 인덱스에서 index.txt config를 바꿔야 돼요. 이런 식으로 가져와서 이렇게 해야 됩니다. 원래 여기는 바닐라 런타임 모듈로 돼 있으면 이 밸런스를 구현을 해야 되는 그러니까 프로토킷의 밸런스 모듈을 구현을 해야 되는 꼭 그런 제약사항이 있어요. 만약에 안 그러면 모듈가 나기 때문에 에러가 떠서 안 되니까 여기다 지워서 이러면은 정상 작동이 됩니다. 근데 만약에 그 바닐라 런타임 모듈을 사용하고 싶다, 뭐 밸런스를 구현했다 싶으면 바닐라 런타임 모듈을 넣으면 됩니다. 대신에 그러면 이 컨피그에 그 밸런스에 대한 컨피그를 또 다시 작성해줘요. 그러니까 만약에 이게 채팅이 바닐라 런타임 모듈이면 여기에 밸런스 땡땡하고 토탈 서플라이를 넣어줘야 되는 거죠. 네, 그렇게 되면 여기는 그렇게 하면 끝납니다. 그래서 그렇고 그리고 하나 더 해보자면 여기서 아까 말씀드렸던 CK 프로그램을 어떻게 이게 사용되는지 보여드릴게요. 여기서 시간이 많이 남지 않아서 좀 빨리 하는 거예요. 근데 그 GK 프로그램은 좀 다르게 클래스가 아니라 함수로 되어 있고, 그리고 퍼블릭 인풋이랑 프라이빗 인풋이 있는데, 프라이빗 인풋은 여러분들 생각하시는 것처럼 제로 놀리지 특성이 있는 거고요. 퍼블릭 인풋은 이렇게 나중에 보여드릴 텐데, 그 이렇게 뭔가 퍼블릭 인풋을 창조를 할 수가 있어요. 그래서 이걸로 또 많은 걸 할 수 있는데 어떻게 하는지 제가 보여드리겠습니다. 제가 하려는 건 베이지 체커고요. 그래서 뭐 신원 인증 같은 거 할 때 나이가 20살 이상이냐, 어덜트냐 이런 거를, 이런 컨스트레인트를 조사하는 겁니다. 그래서 그리고 지금 여기 퍼블릭 인풋이 이렇게 있는데, 사실 이게 하나로 되어 있어서 제한되고 있지만 따로 스트럭트, 필드 스트럭트나 클래스 익스텐드에서 좀 멀티플한 퍼블릭 인풋을 쓸 수가 있습니다. 근데 일단은 여기는 이렇게 할 거고, 그 나이를 체크하는 함수를 만들고, 그래서 여기는 일단 프라이빗 인풋을 넣었는데, 일단 여기는 제 나이, 실제 나이 이런 게 들어가겠죠. 실제 유즈 케이스에서. 그리고 퍼블릭 인풋으로는 20 이런 어덜트가 되는 기준 이런 거를 설정할 예정입니다. 그래서 결국에는 이게 그 뭐냐, 이거 테스트를 통해서 보여드릴 건데, 이거는 붙여도 그래서 여기에 서드에 들어갈 내용이 스탠다드보다 네 나이가 많냐 이런 거를 조사를 하는 거고, 이게 또 하지만 어덜트 프루프입니다. 그래서 스탠다드가 120이면은 20살 이상이라는 걸 증명하는 거겠죠. 이거를 그냥 하면 안 되고, 여기서 익스포트에서 클래스를 정해서 하겠습니다. 네, 이런 식으로 해서 그런 다음에 베리피케이션 키를 컴파일한 다음에 전용으로 이렇게 검사를 해야 돼요. 여기서도 한번 테스트를 해볼 겁니다. 여기서 테스트를 했을 때다 맞게 나올 텐데. 노드 버전. 노드 버전을 바꿔야 돼. 조금 걸리네. 네, 그래서 cut-off age is true for 나오고 verified true가 나왔어요. 그러니까 뭘 검사를 했냐면 제가 이게 이 스탠다드 기준 cut-off age를 20살이라 두고 제 나이를 32살이라 가정하고 이렇게 놔뒀는데 이제 제 나이가 32살 넘었다는 거를 증명을 한 거고, 그리고 여기서 퍼블릭 인풋을 리트리브해서 greater than을 조사를 했는데, 그래서 뭐 스탠다드 에이지가 터무니없진 않은지 막 이런 걸 조사를 했어요. 그리고 사실은 이거 그냥 뒤에를 까지 않고 이게 20살로 기준에 측정한 게 맞냐라는 그런 것도 검사를 할 수 있죠. 그런 다음에 이 컴파일 할 때 나온 베리피케이션 키로 이렇게 검증을 했더니 결국에는 우리가 괜찮게 나와서 2가 나왔어요. 네. 알려드린 건 여기까지고 수고하셨습니다. 오늘 어디 가죠? 시간이 조금 남았으니까 이게 왜 이게 답인지 왜 10이 답인지 한번 논리를 펼쳐보실 사람을 구합니다. 이게 왜 이게 답인 걸까요? 왜 정말 심플한 프로그램 모듈러스랑 관련했어요. 모듈러 오퍼레이션이랑 관련했어요. 모두 14 맞습니다. 좀 빨리 끝났습니다. 수고하셨습니다.
Okay, so our the sessions we prepared is all done. So we have another networking party until since 6 p.m. to 9 p.m. So yeah, 10 minutes later, maybe there will be the barbecue party, some trucks, and then you can get some your dishes, and then you should go to the rooftop and then enjoy the meal, and then do networking. So thank you for joining this workshop. I'm very happy to meet you all guys. Thank you. Thank you.